Hello, this is Álvaro Rodríguez. I'm a solution engineer at StreamNative. I'm going to talk to you about the Apache Kafka API, the unofficial standard for streaming. So, well, I'm a Spaniard from my accent, as you can see, and I live in Switzerland. I have 20 years of experience in computer science. I have been working with Apache Pulsar the last 2 years in StreamNative, and I like a lot open source. I use Lineage OS, and at the same time, I love what Randall Munroe is doing with XKCD, so you will see a few comics from him. But let's focus first on the agenda. Well, we are on the Data Streaming Summit, so I think the first step is only to define what we can consider event data streaming. The second one is that I will try to define an API from scratch. I will try to push it to become the standard, and I will show the problems that can arise to this API or any others. And later I will talk about the actual real status of the data event streaming and where we will go in the future. So let's focus here first on the basics. So we need to agree in what it is event data streaming. So the event data streaming appeared because the batch processing was really slow for real-time analytics. The main idea was to have a lot of producers sending data to a main point and being able to ingest it really fast and consume it really fast to provide real-time insights. There are a few requirements that is like the event needs to be ordered and there should be low latency. After the events arrive to the platform that is doing the event data streaming, the data could be persisted, could be transformed, it could be used for aggregation, or it could be replayed. This is why you need to have it persisted, because maybe you will need to rerun your analytics. And this is used for data ingestion. So when you have a lot of entities sending data to a point, so the main origin was when everybody has a web browser, and now it is much more in use because everybody has a phone. So it is basic piece in the development or almost any application. And it is the amount of data that it can move is massive, and the throughput could be huge depending on the amount of event emitters that you have, but you always have a requirement to have a very low latency. And well, as data streaming platform, you can have a lot of products. So in the first line, I put only the open source one and the platforms that are that are more or less public. The other ones are based on it. And the most important from my point of view at this time is Kafka and Pulsar. From Kafka, that was created in 2013 from LinkedIn, it appeared Confluent, the creators created Confluent. And from Apache Pulsar, it appeared StreamNative. Pulsar was created in Yahoo. Well, as you can see, there is a lot of big companies there, and it is really a market that is really huge. In order to create this standard or this API, I will use a made-up platform that I will call Nietzsche, and that I will use for showing you what would be the basics of the API that I will need to define. So I will move to defining what would look like an event data streaming API, to not enter into details of any of the other ones. So I will do some suppositions here that will help me on the next step. And the idea is that it will be the first data streaming platform. So I will suppose that before there were only batch processing. And I will try to avoid any architectural decisions on it. So I will do it like architectural independent. At the same time, as I made it, it's perfect. So the throughput of the event is massive. There is good performance, reliability, and latency is low. So there is no issues on it. It's working as expected. So basically, my Nietzsche platform would looks like more or less like this. So this is the only architectural decision that I'm going to show you. Is like I will have n brokers that will hold topics that will each topic will be related to a source of data, or it will have something in common, but that we can split in different partitions. The idea is that we can escalate the number of brokers, and at the same time, we can escalate the number of partitions. Because that is really important to have a very nice throughput and low latency. So this is like the only architectural decision that I will show you is this one. But in order to control these topics, brokers, etc., I will need a Nietzsche admin API. And this Nietzsche admin API will be for administrator. They will be able to create topics, administrate how many partitions they have, and distribute it if needed over the cluster. Then I will need a Nietzsche producer API. And this Nietzsche producer API will be used only by the producer that will send the events to one topic or several topics. Later, we need something to consume. So we create the Nietzsche consumer API. And as we mentioned, you can later aggregate or modify or use the events that you have in the topics to create new topics. And you will use Nietzsche Stream API for that one. As we don't want to live alone, and we want to get a huge ecosystem because the events can be originated in very different platforms like business intelligence platforms, CRMs, support ticketing system, etc. What we will need is like a Nietzsche Connect API that will make simple to connect to external system. So this will be my basic API. And if I compare it with other, it's basically the same APIs that other products have. And Apache Kafka has it, Apache Pulsar has it, NATS and Apache Iki has it too. And the thing is that any other product that arrives to the market, we need to have something similar, create their own or copy a previous one. This API will be used by the ecosystem, by the language libraries that will use my platform. And the advantage is that if I have somebody using a Java library that is working perfectly, maybe they can migrate easier if I implement the same API. But why there is not a standard here? Well, the thing is that all the platforms try to become the standard. So, well, there are, I would say right now, there are 4 standards, or they are trying to push for 4 standards, but there is only one that is the one that is the standard. And there was a try in 2018 with an open messaging implementation, but the truth is that it is not in use. And here is the open messaging initiative that it was, the idea was that it was a cloud native, vendor neutral, and open specification for distributed messaging. And this was a little bit more complete than the API that I mentioned, because in my API, I only focused it in data streaming. I didn't talk about messaging queues, but in this open messaging initiative, that was implemented too. It was added. But as I mentioned, it was not adopted. So yeah, it's a shame. Maybe it could be used in the future. But as I'm the creator of a Nietzsche platform, what can I do to make it the standard? If it's good if I make the standard, because I will control a lot of things later. And the advantage that I have as I choose this Nietzsche platform to be almost perfect, I will choose to make it that it was the first one that solved the problem. So it has an early adoption. There was no competitor at the beginning, and it was working. So it was showing the maturity because it was having a lot of use cases that apply to my platform. They battle tested it. They improved my platform too, so they make it really resilient. Based on that, what happened? The ecosystem will come, and that will increase the platform value, and that will increase too the possibilities that people will copy my API and will use it. But there's a little bit of social pressure on it, but well, it can happen. So let's talk back about what Nietzsche API. If I suppose that other architectures or other products will copy it, so maybe if the Nietzsche API is flexible enough, then we'll work with different architectures. It will be architecture independent, like with Apache Kafka. And here I want to show you, is the first time I show you the Apache Kafka architecture, but for example, in Apache Kafka, the architecture of the show is like this. It's quite similar to my drawing before, but in this case, the brokers hold all the information, all the data from the topics. The advantage of this is that it's really fast. I can write and take the data really fast, and I can optimize it for data streaming because I can do batch acknowledgement, for example, to make it really, really fast. It's really interesting. But my Nietzsche API, it was architectural independent, so maybe it worked with Pulsar. And if it worked with Pulsar, the architecture is slightly different. So the the data is stored in an Apache bookkeeper cluster. So the data is slightly farther. That gives us some flexibility advantages. And finally, there is not too much impact in speed or latencies. So, well, it's good. Maybe Apache Pulsar can adopt my API to use it. But then a new architecture arrives, and this is warp stream architecture, and it's quite similar to all the architecture of StreamNative Ursa 2. In this case, the storage is not in Apache Bookkeeper or inside the brokers. The data is stored in S3. That is really good because it's cheaper. Okay, so then if my Nietzsche API is architectural independent, it will work like a charm. But in any case, all APIs has issues. You cannot solve these kind of problems with the API because the APIs all are opinionated. And there is like 2 laws there that I write that down, that it can implies that my API can have leaks on the architectural decision that I'm taking behind the scenes. And sometimes this can be a problem because it will make the evolution of the API, or the evolution even of the platform, slower, especially when you get a big ecosystem. Because the new features that you need to add to the API could break existing integration, and the ecosystem will make you break your evolution. And especially, and if there is architectural changes needed on your platform, maybe as you are leaking the architecture on your API, that will change the API, and it will make things slower. So, well, there could be a lot of integrations that are broken, and this is you will be blamed for any change on the API. So we need to take care with this evolution. In the case of the Nietzsche API, my questions will be: could it be really compatible with our architecture? I show it. Could we add new functionalities or improvements to it? And it is stable, the API. If I define the API before new needs arrives or new architectures, maybe I didn't think about it. So this is one of the problems that my Nietzsche API could face off. And now I will talk about the actual status. So if I should be honest, it's like is literally the Apache Kafka API is the unofficial standard, and it is clear. It was the first product on the streaming data that helps Kafka to do it, and it was open source in 2013. And Confluent, that is the company that is behind the creation of Apache Kafka, considered that Apache Kafka API is the de facto standard since 2021. And there is a few reasons for that. And it's like, it is an open source standard, so that's good. It has a big ecosystem, a big adoption, and it's mature enough. So yeah, everybody using Apache Kafka. The ecosystem adoption is so huge that the joke could be that the only language without Kafka support is COBOL. But that is not true. In fact, IBM is adding that in 2025. So yeah, no other platform can fight against that. It's really impressive. So if I go back to my streaming platforms, that I can show, that I show you before, what we can see is that there is a lot, but when I go to the ones that have Apache Kafka API support, then I only remove a few of them. The market is going there already. But if I move to the ones that has under the hood Kafka, then I reduce it a little. So this is because there is other architectures working. For example, WarpStream, Redpanda, AutoMQ, BufferStream, StreamNative, and Pulsar. The AutoMQ is with an asterisk because it is a fork of Apache Kafka. They leave the same interface API, but internally is different. It's an open source project. So it could be much more compatible because of that. So when I mention the compatibility support of Apache Kafka, if behind the Kafka API there is an Apache Kafka cluster, then 100% compatibility with Apache Kafka API is easier. But even Confluent, that has more or less is very important in the community from Apache Kafka, when they implement architectures that are slightly different than Apache Kafka, they face compatibility issues. So they have the freight clusters, and there they are like, they don't have transactions, they have problems with the potent producer, and WarpStream, that now belongs to Confluent, mentioned the limitations too that they have for the compatibility. But what it is really interesting here is that in 2023, before WarpStream was bought by Confluent, they were complaining when they were implementing the compatibility. They were complaining about an already architectural leakage that was happening in the Kafka API, because WarpStream agents are stateless. So this is an architectural change, and the Kafka protocol assumes an incredible stateful system. You can find that sentence in the blog post that I set it there. So there is a big interest in the companies that say that they are compatible to Kafka API to validate the compatibility. And Jepsen is an open company that it's doing some tests, really rigorous tests and really deep. And they have done some tests with Redpanda and BufferStream, and they found some issues on the product, but this is normal, it's software, so this happens. But they have found issues on the protocol API for the Kafka API, with a special mention to transactions. And why do I mention this? Because when you find a problem in the product that is tested, okay, you can solve it. But when you find problems in the protocol, this is much more in-deep issue, because it will force the API to evolve. And then compatibility will be break with evolution. And this is what Jepsen said about transaction API. And it's a strong sentence. I think, well, the APIs are alive and it should evolve. But transaction API is there since 2017. And this is something that is happening now. So everybody that says now that it's compatible with transaction API, well, it is not free of errors there yet. In other kind of problems, what we can see in the Kafka API, there is a limitation. As I mentioned before, Open Message Initiative was adding message queue. And at this point, Apache Kafka is adding message queues too. And this is really interesting. I want to talk a little bit about that, because I think there could be problems on that functionality. And as WarpStream and StreamNative also shows, there are changes coming into the StreamNative, into the streaming world that will affect the architecture. There is a very good blog post from our company there that mentioned disless, stateless, and leaderless. For example, stateless and disless is WarpStream. So when the architectural change, maybe the Kafka API is not ready for it. And the Kafka API will evolve. So all the compatible products we need to run behind after the standard. We'll need to follow it. And it will be complex because it will be a lot of changes. For example, let's focus on the queues. So it is not yet implemented. It's mentioned in Apache Kafka 4. But one of the problems that I see here, and it is mentioned partially when you follow the development, is that Apache Kafka was designed from scratch to be really fast delivering messages, because it was one of the requirements from data streaming. But this is not going to match well with individual acknowledgement that can happen in a queue. And this will make the development of the queues in Kafka really complex. Even for example, in Apache Pulsar 4, that includes the queue by default, there has been some improvement in Apache Pulsar 4 because the performance can be hit really hard when you have queues. So I recommend you, if you need a queue that is a subset of data streaming, because you have producers and consumers too, and you need both use cases, please use Pulsar. On the other part, there is the architectural flexibility. From my point of view, not all architectures match well with Apache Kafka API. And this is something, as I mentioned, WordPress was complaining about that in 2023. But there are other issues there. For example, AutoEnqueue has made a new improvement, a KIP for Kafka, like literally 2 weeks ago, to unified service storage. And this is really interesting because it could improve a lot the Kafka API. Because it will make a storage independent of the brokers. So this is really interesting. And I think that the WordPress stream acquisition from Confluence shows one thing, that even the implementation for Kafka API to be flexible with the architecture was not easy to do because they bought WordPress stream. So it was cheaper to buy flexibility than to develop it. In any case, if Kafka implements the KAP that was proposed by AutoMQ, that will make the architecture of Kafka much more closer to Pulsar. So, well, Pulsar has the flexibility already. So, from my point of view, the status of the Kafka API is that there is already architectural leakage. The evolution of the API could become slower because there will be changes in the architecture and in the functionality. And the lack of flexibility is already shown there. So my guess is that compatibility, it's going to become harder. And even if a lot of products try to be compatible, this will be difficult. In any case, if we are trying to propose a new alternative, what we will look for? So we will try to look for more flexibility in the architecture, less architectural leakage over the API, and a faster evolution. And this is where Pulsar comes again. So the proof that Pulsar is flexible enough for this is that StreamNative has been able to release StreamNative Ursa. It includes messaging already. It is unifying storage already too, and it has evolved. It is diskless, stateless, and leaderless. So you will be able to save cost thanks to that. And on top of that, it tries to be compatible with Apache Kafka API. There is some problems, as WordPress stream shown before, but it is trying, and it will be really, really a big advantage for this when everything is mixed together. So what is the future? Well, the future is that, well, Apache Kafka will keep being the unofficial standard during the next years. It's difficult to fight against the ecosystem growth that, unless the ecosystem growth change a lot, I would say the Apache Iceberg project and Delta Lake House, if that change the ecosystem, that can affect the standard taken. And there will be a lot of evolution coming from other products. So my recommendation to you is keep in mind other options, please. So check Pulsar API, try to use it. If you see it is easier, use it. So, well, thank you all for your time. I need to thank a lot of people in the StreamNative that helps me with this presentation, and I hope you have a good Data Stream Summit. Bye-bye. Thank you all for your time.
Awesome. Thanks a lot, Álvaro. That was great. Lovely content there. If there are questions for Álvaro, please put them in Q&A. I can already see some of the folks have been chatting, adding comments. Thank you for doing that. If there are any questions, we can take them now. Awesome. We don't have any questions so far. I know as I think it was mentioned in the email, the recordings will be sent after the event. I don't know if actually live audio is allowed or like, if possible, but yeah, at least if there are questions, feel free to put them in the Q&A. Peter is working on one. Okay. Great. So wait for another few seconds to see if there are other questions. If not, then we can conclude. I'm just going to wait for Peter to see if he's got one coming up soon.
Yeah.
Any last comments you want to add, Álvaro, while we're waiting for any questions?
No, there is a question there from Peter.
Oh, there's a question. Okay, let's see.
Yeah.
You want to take that? Go ahead.
Yeah. So, well, there is a lot of KIPs ongoing. So I mentioned only that one, but yeah, because it was interesting to show that where the Kafka is trying to go. So Kafka is trying to move to a more flexible architecture, and they are trying to push it there. But as we have seen with queues or with transactions, adding functionality is complex in a product so big as Kafka. So even if the KIP is there now and it was created 2 weeks ago, my guess is that it won't be added in less than 8-9 months. It will be complex to add it. And for example, there was another very interesting KIP that I crossed literally yesterday. That what they are trying to do is, what I see is something that we are doing with Ursa too. So they are trying to do it stateless, not only storage, unified storage, but they're trying to do it stateless. And there is another KIP that is going there. So from my point of view, they are trying to do what we are doing with Pulsar in StreamNative with Kafka, but it's going to be slow because they have a lot of architectural leakage on the product. And I think that is the main problem. It was the first one, and you needed to do it fast, and it was working. So you don't think too much more about the platform. And I think this is where Pulsar flexibility will come and will beat Kafka. This is from my point of view, and I'm biased, but I think it can happen. It will happen. But the next KIPs, I think it will make Kafka much more similar to Pulsar. They will look for that, and they are pointing to that direction.
We hope that was helpful, Peter. And I don't see any other questions. I know the next session is going to start in 5 minutes for the deep dive. So yeah, if there are no other questions, let's see if there's another one actually. A huge spreadsheet. Go ahead, Álvaro, why don't you?
So the problem here is I didn't focus too much in the compatibility of Pulsar or compatibility of any product with Kafka, because it's going to be really difficult to be compatible with all of them. And the thing is that any new KIP that will affect the Kafka API, for example, the implementation of queues, will mean that everybody that is compatible with Kafka will need to adapt to this one. So there will be a delay on that one. And each product will be faster or slower depending on the effort of the implementation. For example, the queues in Kafka should be easy to implement with Pulsar behind, because we have it already, the queues. But for the rest, we will see how it goes. But even if you say that you are compatible with transactions, Kafka transactions are broken already. So you need to take care when you say I'm 100% compatible with Kafka API, because maybe the Kafka API is broken. So you need to take care with that one.
Cool, but I think I like that idea. Somehow, having some sort of information about the comparison of the KIPs to what we have. Not all of them might be compatible, as you said, right, Álvaro? But at least whatever information we can share from sharing our point of view on what is the equivalent functionality. Yeah.
Yeah, I think about the KIP related to the stateless, I think is called these less topics, it's really interesting because it's quite similar to our Ursa implementation. I have some internal discussion about that, and it is quite similar. So if we want to make a one-to-one, we can say that that one is Ursa. We can say, I think we can say that. So yeah. Yeah, but you're right. Even if a KIP is filled, that doesn't mean that it's supported yet, and it will take time. So the KIP for Q, I think it was open like, I don't know, maybe 3 years ago, and they implemented now in version 4. And past week in current, they were moving the version release to 4.3. In the capture that I attached, it was 4.2, and they were already in March. They were telling me it was going to be in 4.3. So I guess maybe it will be 4.4 if we are lucky, and we will see it.
Cool.
Yeah.
Let me see if there are any other questions. I know we're top of the hour. We are 1 minute over. We want to give you like 4 minutes break before your next session. I'll give another 5 seconds to see if there are any questions. If not, then we will let you have that break before the next one starts. Okay, great. I don't see any other questions, Álvaro. So thank you so much. This was great content, and thank you everyone for joining today. And stay tuned. There are more sessions still going on. So, we'll see you there. All right.
Thank you. Bye-bye.
Thank you. Bye-bye.